Hello everyone, my name is Kadir Genç. Today I will show you the Go language, what I learned about Go language and inform you about the Go language. Let's start. Exploration of Go language. The origin story is Go began during second half of 27 at Google. Three gentlemen from Google, Robert Griesmer, Rob Pike and Ken Thompson, were trying to tackle some of the engineering challenges they faced. Google, due to its scale of operations, faces engineering challenges unlike many other organizations. Selection criteria for the trio to identify which programming language to use centered around three main considerations: efficient computation, efficient compilation, efficient execution, and ease of programming. Though they evaluated many of the existing languages, they couldn't find any language which offered all three of their primary considerations. That realization led them to think about creating a new programming language. Thus, the seeds to develop Go were planted. The design began in September 27 as a 20% project at Google. As things progressed, many others joined as well. In January 28, work on initial compiler started. The language was open-sourced later in November 29. It took a few more years to release first stable version Go in March 2012. Thus, the story of Go started and continues ever since. The mascot. Can a programming language exist without a mascot these days? That will be a bit lame, isn't it? No worries, that's covered as well. Go has a mascot too, called Gopher. You can see Gopher right here. Interestingly, initial version of the mascot was created by Rini French long before Go was born. The mascot was later adapted for the Go project. Design goals of Go. When Go was in the design phase, its designers had a few goals in mind. These goals were identified based on what they were trying to achieve and learning from drawbacks they saw in other languages evaluated. Simplicity. First and foremost, a simple language with clean, consistent syntax was the target. Keeping keywords to a minimum was one of the means to achieve the same. A lightweight type system with no type hierarchy was desired in order to reduce complexity. Implicit conversions were purposefully kept out. It was felt that a strict separation between interface and implementation would keep things more simple. Composition over inheritance was another preference. Scale. Support for large-scale programming was one of the main objectives. This had two aspects: system scale and engineering scale. Support for modern hardware. Many of the languages available at that time, like C, C++, Java, were designed prior to the existence of modern hardware. Go was specifically designed to take advantage of the modern hardware. Coding efficiency. When it comes to writing code, ease of programming was one of the desired aspects, similar to that of a dynamic language such as JavaScript or Python. But when it comes to efficiency, preference was to have something similar to that of a statically typed compiled language such as C, C++, or Java. Type safety. Nobody likes type issues to pop up at runtime in production environment, so being type safe was important. Memory safety. Nobody likes memory issues either, so the ability to handle memory in a safe way mattered too. Weather runtime. A runtime environment with efficient, latency-free garbage collection was the target. In addition to that, they wanted to have built-in strings, maps, and communication channels for intra-thread communication. Better package model. A good package model goes a long way in keeping the codebase maintainable. Explicit declaration of dependencies was a goal which would also have to improve build time. What's the goal? The design goals mentioned above laid the foundation for Go's features. What did they achieve after they had set out to build the language? In summary, they were able to build a language which is easy for humans and efficient for machines. Let's explore a bit more. The human angle. The language has a simple, concise syntax which has only 25 keywords. Less keywords mean less complexity with runtime. Basic syntax is mostly C-family, with some inspiration from Pascal, Modula, and Oberon for declaration and packages. The statically linked binaries approach reduces runtime complexities even further. Building concurrency constructs allow programmers to write multi-threaded applications in an easy way. Go uses a different approach called goroutines, which are lightweighted threads for multi-threading. Communication and synchronization between goroutines are handled via a typed thread safe mechanism called channels. Built-in support for generic maps, arrays, and slices to improve coding experience. The machine angle. Go programs are compiled into machine code. This improves performance significantly since there is no middle layer such as virtual machine involved. Being a garbage-collected language allows programmers to not worry about memory management. Memory-safe mechanisms such as nil references, runtime bounce checks, and default initialization of variables help at runtime. Interfaces are used to implement composition. Overall, the result of these choices led to a statically typed and compiled language like C++ or Java, but without any virtual machine, which in many ways feels as lightweight and dynamic as JavaScript or Python. What's not in Go? Does that mean Go is everything? Certainly not. The designers made some choices on what not to include. Go does not have a subclass, nor does it support inheritance. It takes an unusual approach to object-oriented programming by allowing methods on any type, not just classes. This is done without any form of type-based inheritance like subclassing. There are no constructors or destructors, no control structures associated with error handling, similar to the try-catch finally paradigm, is available. Does not have pointer arithmetic annotations or implicit numeric conversions, and a few more are missing features. That doesn't sound very assuring, isn't it? Let's try and understand the rationale behind it. In normal scenarios, most languages would like to add as much features as possible, but in case of Go, as we can see above, many features were left out. That was an intentional choice. There are many reasons to do so. One of them is clarity. Clarity was considered as a critical feature. When reading code, it should be clear what the program will do. When writing code, it should be clear how to make the program do what you want. Sometimes this means writing a bit more clearly instead of invoking an obscure function. Do more with less. More features do not necessarily translate to better language. In Go's case, less is more. What can we build using Go? There are many use cases where we can use Go. Main use of Go comes in developing cloud network services. A few of best-known examples are Docker, Kubernetes, Istio, and Prometheus. Another area where Go shines is DevOps site reliability engineering. Building such tools in Go provides a better performance. Many of the well-known command line interfaces are also written in Go. Two examples are kubectl and GitHub's CLI. You can also use Go for web development as well. It has good support for protocols such as HTTP2, databases such as MySQL and PostgreSQL. Where does Go stand then? How does Go fare in the industry now? More than 75% of the projects in Cloud Native Computing Foundation are written in Go. TOB declared Go as the programming language of the year twice, in 2009 and 2016. Though Go was initially designed as a system language, it has now matured as a general-purpose language. The big companies who uses Go. First of all, Google, creator of Go, used in various internal systems and tools. Then Uber, high-performance microservices and real-time event processing. Netflix, used for building performance-critical backend services. Dropbox, migrated performance-sensitive parts from Python to Go. Twitch, backend systems for handling concurrent streams and chat. SoundCloud, microservices and backend tools, Cloudflare, networking, DNS services, and high-performance systems. Twitch, again, for real systems including chat and streaming components. Medium, backend services, Heroku, routing and infrastructure services. Thank you all for listening. Hope you learned something about Go. See you later.